Hello people, I'm Bharat Acharya. Welcome to our new lecture. Today I'm teaching you something very important. You will remember this lecture for the entirety of your career as a computer engineer. Alright? Pay attention. I'm showing you how to make searches faster. Shh. Do we need to make a search faster? Is searching an important thing in a computer? Absolutely. The entire computer world works on the principle of searching, and the ability to search faster is what will make your app work faster. I'm going to give you so many examples to make you understand this. The biggest market leader of this industry, Google, became Google because it could search very fast. This is what took Google from an average company to something phenomenally big, and we know the result today. So before Google, there was 𝗚𝗏𝗏, there was America Online, there are various search engines. We are from the generation, we've seen that. And all of them, you type a search string, hit enter, and then wait for a few seconds for the result to pop up. And that was our life. Then came Google in late 90s, 96 if I remember the year correctly. So fast, you enter the search string, hit enter, before you blink your eye, the results are there. That's what threw all other search engines into the bin. Google became the market leader. It got everybody's attention. Everyone used Google to search for anything you want. That's where it placed ads. That's where it started making in the billions that it did. Created YouTube, created Android. The rest is history. All of this from the ability to search fast. This is not a lecture about Google. This is a lecture about a search algorithm. As I always say, if you don't know the purpose behind learning something, what's the point of learning it? I've seen so much content about binary search where people are explaining the whole algorithm without telling people, why are you learning it? What's the point of gaining knowledge like this? You learn the answer, you write in the exam, you get your marks, but you haven't gained any knowledge. You don't know where to apply it. Anyway, so Google was just one example. Think of any other example. Think of any app where you buy. Okay, Amazon, very popular buying app. It could be any other app that you prefer. Doesn't matter. You open the app. What's the first thing you do? What's the first thing? You search for the product you want. Now, Amazon has an inventory of billions of products. From what you have typed, it should be able to pick up the top 10, 15 products that you may most likely buy and throw it on the screen before you can blink your eye. And you're not the only one on Amazon at that point in time. There are millions of others at the same time, and it should be equally good for all of them. That means the searches have to be really fast. The entire survival of Amazon is based on the ability to search fast. Again, Instagram, again, could be any other social media app. These are the ones I use, so I'm talking about them. Not that anyone's paid me for it, but yeah, they're the most common ones. So you're on Instagram right now. What's the first thing you do? Okay, you don't type the search string, but you have a whole feed. Without you asking for what you want to see, there are lots of stories on the top. There are lots of posts in your feed, automatically picked up by Instagram. Of course, from your habit, the people whom you like to see, the kind of content you like to see, the places whose contents you like to see, etc. So it has all those keywords. The moment you open the Instagram app, it looked at all the keywords, it searched amongst all its billions of content that it has available and picked up the 10, 15 that you need to see and threw it on the screen before you blink your eye. And if it doesn't do that, you open Instagram and it takes seconds to create the feed, forget about it. The app won't survive. I can go on. That's a whole different between learning from a person who's just creating videos and someone who's been teaching these things for the past decades and used in the industry. The ability to search in a big database quickly is the essence of most applications that we create. And that is why, as a programmer, you need to know this. You will be asked this, whether it's your placement interview, whether it's GATE exam, whether it's anything. All right. So let's begin. What's the most, first of all, some basic points about binary search. I'm just jotting these points right now. I will explain all of them to you. The first thing I explained super fast. How? You'll come to know very soon. It has a time complexity of O log n. They ask you this, what is the meaning of this? All right, when I say they, it's everybody whom you may be answerable to. You should know this as an engineer. The list must be sorted. Yes, binary search works on the principle that the list that you want to search in must be sorted. So you say, students say, sir, that means first we have to spend time in sorting the list. True. Does that mean it's a drawback? No. See, some people look at the first excuse to stop learning a topic. And some people who are really serious look at all the problems and then tell themselves, no problem. I will overcome all these challenges and understand why this topic is taught to us, because that's when I'll understand the real essence of the topic. Look here. Yeah, you have to first keep the series sorted. So that's what most applications do. Instagram has its entire database pre-sorted. Amazon has its entire list pre-sorted. Whenever you add a new product, whoever is the merchant, that product goes and gets entered in the slot where it has to be, but the list is sorted. Why? So that searching becomes fast. And this is no rocket science. This is common sense. You want to search for a page number in a textbook. It's only possible to search quickly because the page numbers are sorted. You want to search for a contact in your contact list. It's only possible because the contact list is sorted. Imagine your 5,000 contacts are not sorted and you want to search for something, you go crazy. So when you know that there is a list from where searches will be performed frequently, it is best to keep the list sorted. It's a one-time effort to sort the list, but after that, all the millions of searches that be performed on that list, all of them will yield super fast results. So the condition of binary search is that the list must be sorted, and it uses the principle of divide and rule, which I'll teach you very shortly. Come. Say I have a list. This is a sorted list. As you can see, there are 10 numbers. The index is 0 to 9. The numbers are 10, 14, 19, blah, as these are the numbers. Okay. As you can see, it's a sorted list. It doesn't have to be sequential numbers, but they have to be sorted. Another list, another list, another list. Okay, I've hidden the elements. Whatever they are, there are 10 numbers. I tell you, search 65 in this list. Okay, you don't know binary search, no problem. You do the normal way, the layman way of searching. What's the layman way? Simplest, I want to search for a number. What is the simplest thing to do? Compare it with the first number. 65. Is 65 the same as this? Let's open this. Okay, these are 10 cards kept inverted. Let's open. Is this 65? No. If it was 65, it is found. We are lucky. It's a lucky day. In one search, we got it. Does that mean every time we'll get in one search? No. Like here, we did. No problem. We will now look at the remaining part, else search here. So what do? Look at the next number. Is it 65? No. No problem. Now we're going to search here. Next number. Is it 65? No, it's not a lucky day. No problem. Keep searching, keep searching. Eventually you got it over here. Element number 7, which means your 8th search. 0 to 7 is 8. On the 8th search, you found it. So what's this algorithm? Compare each number with the number you want to search till the time a match is found. What's the time complexity of the algorithm? Time complexity means if you can tell me with a guarantee in how many searches will you get it. Can you say I will always get it in one search? No. You may take 2, you may take 3. Maximum, worst case, how many searches will you require? 10, because there are 10 numbers. You're not going to do 11 search. If it's not there in the 10 numbers, it's not there in the series. So in the worst case, even if the number is not present in the series, worst case, you require 10 iterations. Are you clear? So that is called time complexity, and the method is called linear search. Why is it called linear search? As the number of elements increases, the number of searches increases proportionately. If you draw a graph, it will be a straight line. So it's called linear search. Are you clear? 10 elements, 10 searches. 20 elements, 20 searches. I'm talking of the worst case scenario. 100 elements, 100 searches. Still okay, 100 searches. I will do, modern processors do work at gigahertz. 100 searches I can live with. But with 1,000 elements, I have to do 1,000 searches. Now this is where it becomes silly. 10,000 elements, I have to do 10,000 searches. No way. Instagram has billions of photos, stories, videos, etc. Billions. To look for one story or reel, if it has to do billions of searches, it won't work. It'll crash. It'll shut down because you're not the only one on Instagram at that point of time. There are a million others, as is with YouTube. What do you do when you come on YouTube? What's the first thing you do? You search the video you want. Even if you don't search, there's a feed created for you, which is picked up by searching from your keywords. Are you clear? So moral of the story, for these searches to be fast, you can't use something so silly as linear search. Linear search is good when you want to compare 4, 5, search within a list of 4, 5, 6 numbers, which is only in theory, only for the sake of understanding. In the real world, you're never searching in 4, 5. I always tell students, if you want to really understand the juice of any algorithm in the whole computer syllabus, whether it's computer graphics, here subject that I teach, microprocessors, microcontrollers, embedded systems, C programming, DSA, etc. If you want to understand the juice of the algorithm, think big, because these are created to handle big amounts of data, and these are created to make big operations fast. So you have to look at the bigger picture. If you have thousands and millions and billions of elements, you're not going to spend billions of searches to find out where the element is. Aadhaar. We are 1.5 billion people in India. All of us have a unique Aadhaar number. So in 1.5 billion, if you want to verify someone's Aadhaar number, you go to the Aadhaar site, enter the number, hit enter. Out of 1.5 billion, it has to pick up the correct entity in a flash. It can't take 1.5 billion cycles to identify the person. So we need faster algorithms. Come on. Here comes our beautiful algorithm that's called binary search. It has a complexity which is just log of n, not n. So if there are 10 numbers, you have log of n to the base 2, which means that power of 2 that can satisfy that. 2 raised to 3 is 8, 2 raised to 4 is 16. That means within 4 searches, up to 16 numbers can be searched. That's the meaning of log of n to the base 2. I'll teach you. Don't worry. Some people are fast. They got it by now. Some people take more time. It doesn't matter how much time you take it. What matters is you have to understand it. Come, pay attention. I have 10 numbers. What does binary search say? What is this algorithm? Don't look at the whole series. You want to search for 65? Attack the middle. Divide the series by half and just hit the midpoint. Your midpoint is 4. Check this number. I want to look for 65. Open this card and see what it is. Oh, it's not 65. If it was 65, in one search you got it. It's not 65, no problem. You know that the series is sorted. I told you, binary search works with the assumption that the series is sorted. Since the series is sorted, you want 65. This number is 35. That means your target number cannot be on the left of this. Has to be on the right of this, which means you have not only eliminated this number, you have eliminated this entire half of your series, and your search will now be focused only over here. Tell me, did you understand? From 1,000 numbers, you look at the midpoint, the 500 number. If you found it, great. If you didn't, you at least know which other side you have to look at, which means in one search, you eliminated 500. In another search, you eliminated another 250. Next search, 125. Next search, 64. 62, 31, 16, 8, 4, 2, 1. 10 searches, 1,000 numbers. I have a series of 1,000 numbers within the 10th search. I can write on a stamp paper and sign on it and say, I will tell whether my number is present or not. And if it is not present, I'll be able to identify that, yes, it's not present within 10 searches in the worst case. Are you clear? How many numbers? 1,000. How many searches? 10, because 2 raised to 10 is 1024. 1,000, a little more, 1,000, so 1024. So that means up to 1024 numbers, 10 searches will do the job. You know what's 2 raised to 20? Now, because the subjects that I teach, they're all computer related, for me, powers of 2 is like what is ABCD for you. I'm really comfortable with them, but you can always take a calculator and verify, pause the video if you want to, or just simply trust. 2 raised to 20 is a million. A million, which means for a million numbers in a series of million numbers, okay, 10 lakh, 20 searches will reveal where the number is present. 20 searches. Linear search, a previous method, in 20 searches could look at a series of 20 numbers. Here in 20 searches, it can look at a series of a million numbers. Are you understanding? Your whole entire phone's photo album, all the images, within 20 cycles can identify the image that you want. Are you clear? Well, you know what's 2 raised to 30? A billion. 2 raised to 31 is 2 billion, which means in 31 searches, it can pick up anyone's Aadhaar number. In 32, 33 searches, it can search all of YouTube. And so on. 32, 33 searches. For today's processor, 32, 33 cycles are nothing. It's a for loop with 32 iterations, and it can pick up any video you want from the entire YouTube database. So, giving you the point, how fast binary search is. Now, come on, look here. We attacked the first number. Is it 65? No. So, we know we have to search on the right. That means this much part of the series is eliminated, and our focus is only over here. Again, the same algorithm. The algorithm is done. I've already taught you. Hit the center. Attack the center number over here. Now it's 7. I'm looking for 65. Let's open what this is. Oh, it is 65. Got it. 2 cycles. Does it always have to be 2 cycles? No. In a series of 10 numbers, it may take up to 4 cycles because 2 raised to 4 is 16. So 10 numbers up to 4 cycles it may take. Suppose I was looking for 66. It's not here. Now it's not 65. I was looking for 66. 66 is more than 65. That means I've eliminated these 3. Now I'm only focused over here. Either it could be this or it could be this. So I'm going to search here, here. Either way, That means just 2 more searches will be required. 2 done, 2 more. That means within 4 searches, I will tell you where the number is present. If it's not present, then it's not present. Either way, I'll conclude the search within 4 operations. So that is why the time complexity is log of n to the base 2, which means time complexity is that power of 2 which satisfies this series. A series of 100 numbers. 2 raised to 6 is 64. 2 raised to 7 is 128. It is. Alright. So that means in a series of 100 numbers, in 7 searches, I will tell you where the number is present. And if it's not, then it's not. Still, I will conclude my search in just 7 operations. Are you clear? So as the number of elements increases, the number of searches increases in a very slow manner, logarithmically, not linearly, not exponentially, logarithmically. Are you clear? If you draw a graph, just one single element number of search you increase and you double the whole series. Then again, one single search, the number of searches you increase, you double the entire series that you want. Anyway, you got the point. Now, this is just the introduction. Let's develop the algorithm properly. All right. I'm going to take an example. We're going to step by step word the whole algorithm. When you're learning these algorithms, I'll tell you something. Focus on the logic, the algorithm. If you have understood the algorithm crystal clear, writing the program will be so easy, you will not be able to believe it till the time you actually do it. Like our last lecture, we did selection sort. I spent 25-30 minutes in teaching the algorithm. I think we required only 5 minutes to write the program. And I even told you, practice it by yourself. You'll get it in the first attempt. The point is, you need to understand the algorithm. All programs at the end of the day have the same for loop, have the same while loop, have the same if statement. The coding is not the challenge. The challenge is to understand the algorithm, have clear thought process about the algorithm so that you don't get stuck when you're doing the code. Now, look here. So I have a series of 10 numbers. I want to look for 33. Initially, I need to find out where my series is. So I need 3 variables over here. I want your full attention. They are called low, mid, and high. Low and high are the boundaries of your series and mid is the midpoint. Okay. Initially, low is 0, element number 0. High is the last element. So if there are 10 elements, that means the element number will be 9. That means n minus 1. So this is high element, this is low element, and the midpoint is high plus low divided by 2. You can understand how do you calculate the midpoint. Add the 2 numbers, divide by 2. So mid is low plus high divided by 2. That is 9 plus 0. That is 9 divided by 2. That is 4.5. Obviously, there's no 4.5th element. It's 4th element that you take. You ignore the point. So this is low, this is high, this is mid. Okay. Every time you need to calculate your low, high, mid, attack the midpoint, and then create the next cycle till the time your element is found. Come on. So you did your low, high, and mid, and you got your 3 elements that you're looking at. Now, I want to look for number 33. Compare it with the midpoint. Compare search value, that is 33, with M. What is M? 27. If they are equal, you have found. You found your element. Job done, algorithm over. Now, they are not equal. No problem. If the value that you want is greater than this M, R33 is greater than M, you will go right. That means you have eliminated this whole chunk and you're only focused on this part of the series. Are you clear? Yes. If the value was less than M, you would go left. Right now, you're going right. Now, I want to focus on this go right a little bit. When you say go right, that means now this is your new series. I've highlighted it. It should be easy for you to see. I've dimmed this whole part. So this is your whole series. That means this is now your low. Mid comes later. Calculate mid later. Don't try to look for mid. Look for low and high. When you go right, your high remains the same. Your low is the next after the current mid. Tell me, did you understand? The next point up to here, if M, we compared with element M, it is not element M. That means whatever it is beyond this, which means your low will begin from the next element of M. So low becomes M plus 1, high remains the same. This is what happens when you go right. Did you understand this? Now try to say this to yourself again. Try not to look at the screen, look at my face. Come on. Pay attention. When I'm doing in the class, it's very easy for me to just move to the other side of the classroom and tell students, okay, look here, now don't look anywhere else and try to figure this out. Initially your low is 0, your high is your last element, that is n minus 1, and your midpoint is low plus high divided by 2. Compare your search element with m. If it is equal, number is found. Great. If not, if your search element is greater than m, you go right. When you go right, come on, when you go right, your high remains the same. Your low is now the next element after the current mid. So low is m plus 1, high remains the same. Calculate m once again. Calculation of m is the same, low plus high divided by 2. So it's 5 plus 9. What is 5 plus 9? 14. Divided by 2 is 7. So element number 7, that's your m index. Please tell me, did you understand? This is what happens when your value that you're looking for was greater than m. Similarly, I'm going back to the original series. I was looking for 33. I compared it with m. If my number was less than m, I will go left. Now, when I go left, it was less than m. That means it's not m. That means from m up to here, this whole series is eliminated, which means now you will tell what happens, what I'll write next. What remains the same now? L, because I'm going left. L remains the same. High is now m minus 1. Did you understand? Low remains the same. High becomes m minus 1. Please tell me, is that clear? And your midpoint is same. Low plus high divided by 2. So 0 plus 3 is 3. Divided by 2 is 1.5. Eliminate the point. That means it's 1. Tell me, did you understand this? Say this for the last time. If you say this, you understood the algorithm. The rest is just... Come on. Initially, low is 0. High is n minus 1. M is L plus H divided by 2. Compare your search value with m. If it's equal, found. Done. If search value is greater than m, go right. High remains the same. Low will become m plus 1. Calculate m, repeat the process. Similarly, if your search value is less than m, you go left, which means low remains the same. High will become m minus 1. Calculate m again, repeat the process. Keep doing it till the time your number is found or your series is over. Either way, we'll see examples. Come on, come on. Can you repeat? Can you say this to yourself? If you can say this, you understood the algorithm. You'll be able to write the code like this. We, of course, write it. We'll play with it. Come on. Look here. 10 numbers. I'm looking for 33. This is my low. This is my high. This is the midpoint, 27. Okay. Compare 33 with m. Come on, now run the algorithm and show me. Compare 33 with m. 33 is greater than m. That means this whole part of the series is eliminated. Now tell me, what will my new low be? 5. My new high be? 9. High will remain the same. Low will become m plus 1. So this is 5, this is 9, and midpoint is 7. This will be m. Correct? This is low, this is high, and midpoint is 7. This is m. Tell me, did you understand? Come on, next cycle, next iteration. Till now, we done only one comparison. See, in one comparison, we've eliminated so much. Now, 33, compare with m. M is 35. So 33 is less than 35. That means now this part of the series will be eliminated and our focus will be here, which means low will remain the same. High will become m minus 1. So low will be 5, high will be 6, and m will be 5 plus 6 divided by 2. That is 11 divided by 2. That is 5.5. That is 5. That means this element itself is low. This element itself is mid. And this element is high. This will be low and mid. This will be high. Correct? Let's see. This is low and mid. This is high. Correct? Now repeat the process. Compare your search element with mid. Search element is 33, mid is 31. Not found, no problem. 33 is more than 31. That means you go on the right. When you go on the right, high remains the same. Low becomes m plus 1. So low is 6. High is also 6, and therefore m is also 6, because 6 plus 6 divided by 2 is 6. So this is low, this is high, this is m. Repeat, calculate, compare. Your 33 will be compared with m. Remember, you're always comparing with m, and 33 is m. That means your value is found in how many searches? 1, 2, 3, 4. Why? Because there are 10 elements. 10 is up to 2 raised to 4. Even if there are 11 elements, 4 searches. 12 elements, 4 searches, and so on. Understood? One more. Come on. If I want to fool you, I'll take one example. If I want to teach you, I'll take multiple examples. Come on. 19. I will look for 19. Look at the series. I'm looking for this number 19. Okay? Run your algorithm. Low is 0. High is last element. M is half of the 2. Now, 19. Compare with 27. Make it fast now. Compare with 27. 19 is lesser. As it's lesser, we go left. What happens when you go left? This whole section is eliminated. Low remains the same. High will become M minus 1. So this will be high. That is 3. And 0 plus 3 is 3. Divided by 2 is 1.5. That is 1. So M will be 1. High will be 3. Tell me, did you understand? M is 1. High is 3. Low remains the same. Now, M is 1. That means 14. Compare 19 with 14. 19 is bigger. That means now you'll eliminate this part and go right. When you go right, high remains the same. Low will become M plus 1. So low will be 2. High will be 3. M will be 2 plus 3. 5 divided by 2 is 2.5. That is 2. Okay, now every time I want to do the calculation, I won't say the calculation. By now you can do it orally. So low and M both will be element 2 and high will be element 3. Low and M both are element 2. High is element 3. I want to look for 19. You'll compare it with M. M is 19, value is found. Tell me, did you understand? One more example, last example. Purposely, I'm taking an example where the number doesn't exist. Because I'm here to teach you. I should teach you all the cases. Come on, 18. Come on, together. Looking for 18. Low is 0, high is last element, M is the midpoint. Compare 18 with midpoint. Is 18 equal to 27? No, it is less than 27. That means I go left. By now, this should be crystal clear to you. When I go left, that means low remains the same. High will become M minus 1. So this will be high. Are you clear? M will calculate. Look at low and high. This will be high. This is high. This is low. 0 plus 3 is 1.5. M is 1. Are you clear? Now, compare 18 with 14. 18 is greater than 14. That means I got to go right. That means high remains the same. Low will become M plus 1. So this will be low. This will be high. And obviously then this will also be the mid. This is low and mid, and this is high. So mid right now is 19. Compare 18 with the mid element, that is 19. Not found. 18 is less than 19. If 18 is less than 19, so you go left. What happens? Don't look there. No cheating. Don't look there. Look here. When you go left, what happens? Now say from your understanding and your imagination. When you go left, what happens? Look at a series. When you go left, what happens? Your low remains the same. Don't look there, please. When you go left, your low remains the same. Your high becomes M minus 1. If you want reference, look here. First time I compared 18 with 27. 18 was less. So we went left. Low remains what it was. High becomes M minus 1. So low will remain what it was. High will become M minus 1, which means high will come here. Are you clear? And when high crosses over low, when high becomes less than low, that's when you stop. Because you have run out of the series. You either kept going this way and overlapped, or you went this way and overlapped, which means your series is over and your number is not found. You stop. The reason why I took this was because 4 screens earlier, when we wrote the algorithm and we said we were going to make a loop, we didn't make the breakout condition, because that condition, if I would have said it that time, you wouldn't understand, and then it would just be by hearting. Now I've shown you the condition. This is when you stop. This is when you decide it's not found. When low becomes greater than high, or high becomes greater than low, means less than low means the same thing. High should be on the right, low should be on the left. If they cross each other, when simple terms, when low becomes greater than high, you have finished the series. You not found, declare that the number is not found. Tell me, did you understand? Yes? If you wanted me to repeat this, at this point what happened? I compared 18 with my number M. 18 is smaller. Every time it's smaller, what do? You go left. When you go left, look here, when you go left, what happens? Low remains the same, high becomes M minus 1. Low remains the same, high becomes M minus 1, which means high comes here. When high comes here, high will become 1, because M is 2, so high will become 1. That means high is now lesser than low. Low is 2, high is still 1, which means low has become greater than high. This is your breakaway condition. This is where your loop ends. Are you clear? Declaring that the number is not found. Now we are in a position to write the algorithm and run the program. Come on, tell me the algorithm. Accept the numbers, blah, blah, start. In the beginning, low is 0, high is n minus 1, midpoint is low plus high divided by 2, correct? Low is 0, high is m minus 1, midpoint is low plus high divided by 2. Are we clear? Now, I just got a call in the middle, so I had to just flip it. Anyway, now, once you got this is your starting, your actual loop begins. In your loop, what are you going to do? Compare, then evaluate, then either go right, then either go left, repeat. So this is a while loop. What is your condition? This loop should happen while low is less than high. Low should be always less than high, or maybe equal to. If you both low and high both have narrowed down to one element, that is fine. But low cannot be greater than high. So while low is less than or equal to high, you are going to create your loop. What is your loop? Compare search value with the value of m. Compare search value with the mid value. If they are equal, you've found. Done. If search value is greater than mid value, you go on the right. When you go on the right, what happens? Please answer. What happens when you go on the right? When you go on the right, high remains the same, low becomes mid plus 1. And calculate the new mid again. Similarly, when you go on the left, say this. If the value you're searching is less than the mid value, then you go on the left. When you go on the left, low remains the same, high will become mid minus 1. Low remains the same, high will become mid minus 1. Calculate the new mid and repeat this. This should go on happening as long as low is less than equal to high. If by changing low or by changing high, if low has become greater than high or if high has become less than low, your algorithm should break, determining that the number is not present. Done. This is your algorithm. This algorithm becomes this beautiful program giving you this output. You know, I always like students to have good output screens. These are things which we have mastered in the first 2-3 lectures. I told you have to have complete command over your program and your output has to be perfect. In a class of 60 students, about 10 students write really good programs. Normal average. Amongst those 10 students, 5 students write very good logic. You will be there. Now, out of those 5, whom will the teacher select? It's equally good logic, equally good program. Whom does the teacher select? What is the point that makes your program stand out amongst everybody else? A very clean, neat, beautiful presentation, which is what today the world wants. UI UX is what the world wants. Every time YouTube, Instagram, Facebook, all of them, they keep updating their visual appeal. That's where a lot of products are sold, and so are all the shopping apps. So right in the beginning, these are habits you inculcate in the beginning of your programming journey. You focus on code, of course, you focus on logic. At the same time, right in the beginning, be in the habit of creating really good looking outputs. So this is your screen. You ask the user, enter the search value. You run the algorithm, it will tell you search value found in index 5, 0, 1, 2, 3, 4, 5. Indeed, this is index 5. In fact, you can even have more fancy outputs. I put one on Instagram. It looks something like this on my Instagram profile. This is just fancy. You don't have to write this when you're writing an exam, but when you're practicing at home, because we love programming, you can display all the elements with their indices. You can see 0 to 9. You can also point out which is low, which is high, because your algorithm always has a value of low, high. So just place it at the correct place. Your low, high, and your mid, and cycle after cycle. It's the same algorithm. I'm just displaying the whole series after every cycle, showing you wanted 42. It was here, here. 42 is found at index 8. You started from here, so you're searching the whole series. You compared with the midpoint, 27. Not here. You go to this section. Now this is low, this is high, this is midpoint, 35. Not here. Now this is low, this is high. Now this is low, this is high. This is also the midpoint, and you compared it and you found this is 42. Anyway, is how you present the output. All right. You think you'll be able to write this whole program? I'm absolutely sure. Let's do this. Now, this is the whole logic, the entire program, and the whole lecture and the entire course of C programming is there on my website, bharatacharyaeducation.com. I teach various subjects. This lecture, of course, is there in the C programming course. I will also make a course on DSA in the future. It started being produced, but still a long time to go. But anyway, this video is there in the C programming course along with the other 32 videos, the 33rd video if I remember correctly. Starting from absolute basics of programming, controlling your output perfectly, recreating beautiful outputs which appeal to the real world, learning how to use if statements, for statements, variables, characters, strings, integers, floats, all kinds of loops, functions, structures, pointers, linked lists, arrays, 1D array, 2D arrays, passing parameters to functions by value, by reference, sorting algorithms, search algorithm, etc. I want you to be really good at programming. Maybe you're in the first year. Ideally, you have this asset right in the beginning. All through your 4 years of engineering, you'll be loved in your class because you'll be writing programs that people will look for. They will take inspiration from. Teachers would love you because you are the person who is leading the entire class. You take part in those festivals, you get your exposure to good set of people from all different colleges. You'll be noticed and spotted. Your talent will be identified at a much younger age, and that's when you'll grow much faster than the others. Learn programming the right way, learn it from teachers who love to teach. Wish you all the best, do well, we are going ahead. Alright, so let's begin our code. I have